Hello everyone. I hope you all are doing excellent at your end. So, today we are going to start our day one of Microsoft Azure Artificial Intelligence Bootcamp, and this is the day one of our bootcamp. And we are going to this is a 3-day bootcamp where we are going to talk about Azure, how you can deploy your Azure ML services and multiple services that Microsoft offers. And this is Lakshit Pant, your host for today, and I'm DevRel Engineer at Rayskill, and we have our expert Mr. Vishwas Narayan with us, who is taking care of who is handling for this bootcamp, entire bootcamp, and he's your expert speaker for this bootcamp. So over to you, Vishwas.
Thank you so much, Lakshya. Thank you so much. So, hey, folks, this is me, Vishwas Nana. I'm the speaker for the session. And also, a lot of times when you think of architecting a solution, right, let it be in a form of a web app, let it be in a form of an containers or else anything that you just think about. Like, these are some of the form factors in an industry, right? These really have the marketplace. Like, this is where the marketplace is all about. So, when you think of an advanced task, something like, okay, we have to pick this pen, place it down here in a precise location, saying that, what, it has to be ordered and things like that. And all these kind of an deployment, all these style of an deployment really takes a huge amount of intelligence on a computer, but it's just a little bit of an brain cell getting used on a human being. So a lot of times there is a huge chance that can we really get that intelligence on a computer? So what was the solution? That was machine learning and deep learning. So that was it all about. So let me just share my screen. I hope my screen is visible. So a lot of times we forget where the market fit in, right? So let me just explain you why the market fits in with the deep learning, and then let's just go with respect to where can we start learning in depth about the neural network. I can't explain you neural network in an hour. Trust me, it's impossible to do that. But I can give you a brief amount of insights. And as soon as we progress in this 3 days, we will be going towards a lot of things. So let me just talk to you regarding the marketplace, right? So deep learning. So if you think of deep learning, where does it fit in? Medical image processing? Yes. So there is a lot of thing that happens with respect to medical image processing.
Vishwas, are you getting my voice?
Yeah, I'm getting your voice. Yeah.
So there is a glitch between some links. So I just wait for a while because while sharing we have shared. I guess there's a glitch with the link. So I'm sharing the link with the college again. So there is no one right here. So I'm sharing the link again with the college. Okay.
Yeah, sure. Koi baat nahi.
So just let's wait for a while so that they can join now.
Yeah, sure. No
So
problem.
just a second.
All right, no problem.
हेलो मैंने आपको एक लिंक भेजी है. Okay, now they got the day 3 link instead of day 1 link, so now they are joining.
No problem. Yeah, like happens. When you are doing at the scale, right? There's
Yeah.
a lot of things that goes bad. I think you shared the AZTave link, right? Yeah, that's perfect. You have shared them. Done. Okay, fine. Perfect. So yeah, let's just go on and get everything done.
So yeah, some folks are joining. Still, these people are joining. Let's wait for some couple of minutes so that more people
Yeah,
can
yeah,
join.
sure.
Okay. So yeah, we have couple of peoples around here. We have so many peoples right here. So hello everyone. This is Lakshit Pant. Sorry for the glitch. There was a glitch in link, so we have shared the directory link. Sorry from our side. Really apologize for this. So welcome to the session. Today is the first day of our boot camp on Microsoft Azure AI 900, and we are going to talk about cloud computing, machine learning, and how you can integrate both these things. Both are the fire burning technologies right now. You can do a lot of things with both of these tech stacks. So we this is Lakshit Pant, your host, and we are going to organize session for you all from Azure Developer Community, and we have our expert speaker with us, Vishwas Narayan, who is going to teach you about Azure AI and how you can integrate everything and deployment process and everything about Azure AI fundamentals, so that he will cover the entire syllabus that is offered by Microsoft of Azure AI 900 exam. So he's also Azure developer lead for our community. So over to you, Vishwas.
So thank you so much, Lakshit, and also sorry for not giving you the right thing, folks. That's our mistake, and we apologize for that. A lot of times, I was talking about the introduction, right? Where does the market fit in for any of the marketplace that we are talking about? So let it be in terms of hundreds of people coming up and gathering in one place, analyzing about hundreds of people, and then creating a market for it. There you require machine learning, data analytics, and things like that. So a lot of these kind of market is now getting created because a lot of times a lot of engineers have a humongous amount of data that they want to just collect, and they just want to architect the solution around it, and that's how it is. And market is created, market will always be flourishing in this space. So let's just get it started. So a lot of times, let's just start with where does the market fit in, then let's just communicate where can we architect a solution towards it. Because to me, I feel that a lot of times when you are architecting a solution, you don't know the market fit and you just start architecting it. It doesn't make any sense. So let's just start doing it. So deep learning, learning. So where does it fit in? Medical image processing, and we are coming up with self-driving car, and we are coming up with finances and fintech. We are also coming up with a lot of automation. We are also coming up with a lot of optimization. So it can be process optimization, and also today it's also about compute optimization. So let's just address each and every step of it, because a lot of times we don't know where to analyze and where can we architect our solution towards, right? So let's just go on and get everything sorted from our side. So let's talk medical image processing. So let's say you get a CT scan, PET scan, it's photonic emission tomography, tomography is a technique where it's basically saying you that you have a set of x-rays that are moving in and moving out of your body, and how are the images that are getting collected, right? That is where tomography comes into the picture. And if you want some more insights, I have a Google Docs which completely covers about MRI, fMRI, AI in radiology, and the things like that. Like all these things have been covered in this resource here. So I'll be sharing you guys this document. So do check that out as well. So it's more towards like where can we get the right solution for you folks. And this is our humble attempt to just get you that thing. So this will be the link. So do share yourself, and also do see this entire documentation, because if you just click on any of it, what should be your approach will be the first one. I think it's self-driving car is the second one. I think this is AI in finance, AI in radiology. Yes, this is where you can just go back and see it. And also this is where you can see MRI fundamentals. So magnetic resonance imaging is what I'm talking here. So just keep it in mind. So MRI and things like that. So all these things have noise. The image comes out as a noise only, and it requires a lot of optimization. And guess what? Both of these uses deep learning to optimize all these things. So to reduce noise, there is some sort of an algorithm, yes, but today it's more towards the DL, the deep learning aspect. Everything is getting optimized, and every part of it is getting optimized. And now you have optimized it, you have removed the noise, you have the information now. So now it's all about getting the insights from that image. So how do you architect that? So to architect an insight, it's very simple. What we do is we just move towards uh, getting that right approach from our hand. So what we do is we use deep learning. We train to classify or to identify. So there are different ways to classify and identify. There are different algorithms which come in. Segmentation comes in. Image classification comes in. A lot of things comes in. So we'll be moving a step by step. And also, I have a set of Google notebooks here. Like these are the shareable notebooks. So I'll be giving you guys all these notebooks so you guys can check that out. Like all these are written by me. Like a lot of work has been put in. So do read, do understand it step by step, because a lot of times it takes a lot of time for us to understand some concepts. So you guys just take a little bit of time and just move it. So this is where it is, right? So we have to classify, do all these things. So now we learned about it. Next we talked about self-driving car, right? And let me just say you one thing. So back then this identification classification was done manual. So now it's automated. So with the help of DL only. So it's all DL at the end of the day. Different jargons coming up in the same market, but it's all about automating that stuff. So now self-driving car. Oh, sorry for that. So a lot of times when you think of self-driving car, it's also about driving, right? It's also about safety. It's also about architecting and right amount of insights through the data. So data centric approach. So even if you want to do more data centric, you should also know how to collect the data, annotate the data. Everything is getting automated here. So right now, this was done by a human. This is a risk that can be taken by a human. And of course, we as a human are data centric. We learn from the experience. Something as good as, like, how many of you had an accident here? Like, I wanted to know how many of you had an accident here before. Like, I just wanted to know that. Like, a quick round. Like, how many of you had an accident here? Because you can type in yes, yes, yes. And what did you learn from it all? also, like if possible. So it would be great if you guys can write that, because a lot of times when you think of accidents, that's something that you learn from, right? Something like, what, I didn't know that there was a sand on the road and I slid myself out there. So this is how it is. So, oh yeah, Hythan says yes. So it's all about that. It's all about where do you architect that solution, where do you architect towards it. So we are all data centric. So now what happens? So driving requires a lot of actuation, right? So uh, pressing on a gas pedal, accelerator. So that's an actuation problem statement. Accelerator, accelerator, brake, and also gears. Yes, gears also has a problem statement today. And all these were also human centric. Actuation today is done through a DL. And also, if you think of safety, something as good as, okay, opening an airbag. Next, what? Next, what? Thinking about opening the door when you have to go out or something, or something as good as something like, okay, there is a truck very nearby. So if this is a car, sorry for my drawing, it's very bad. So at a distance of 5 meters, there is an bike or something. Let's say a cycle guy is moving in and things like that. Like this has to be detected. All the things at the end of the day uses a sensor, and that sensor data is now being combined through a technique called as fusion. Don't worry, like there is a lot of things that we also don't know, right? We also just keep learning about it every single day. So keep calm, keep composed. We'll go on with some demos and we'll get it done. So all that fused data will come up with some data format, and that will be raw, and the insights has to be got from a DL optimization only. So at the end of the day, it's a human attempt to automate a lot of things that is going behind the market, right? So this is where we architect a solution towards. This is where DL comes and fits in. So I don't think so. I need to give much more insights about the fintech. Fintech is something like, okay, he has a CIBIL score, he has some debts in some bank, and can he be given a loan or something, or something like, can this transaction happen safely and things like that. So automation, of course, you can think like something like robots coming in and giving you food. Optimization, you can think something like you can think of trucking has been optimized in such a way that even if there is no driver, trucks can just move out there and just get that delivery done and things like that. So it's all optimization at the end of the day. So if you want some more insights about the optimization, let me just give you a little bit of an optimization wala insights. Something as good as, my computer is an i3 and it can't run, and deep learning processes today are something which are used in compute optimization as well. So keep a close eye on all these technology as well today. So now we know all these things. Now next what? So let's learn about neural networks. I'll say you how it works with respect to a human brain. Then we'll talk about how it's all about architecting a solution here. So before that, we'll just go through a demo so that you guys can understand what is it all about when I'm talking about here. So now this is a computer vision demo that we are talking here. All right, artificial intelligence. All right. So yeah, that is what we are talking here. So yep. So you can click on this link. You can click on this link, and what you can do is you can really understand how this solution is getting architected, because this link, when you just click on it, it will just redirect you to this thing here. So this is where we are coming up with the Azure infrastructure. So where does Azure fit in? It's everywhere. So to me, let's say you are a developer, you're not knowing anything to be done. I think let me just get the agenda as well so that you guys can get to know. So common artificial intelligence workloads. Yeah, we are talking about that only. So if I don't give you where does the market fit, it doesn't make you any sense. So yeah. So there are some set of images that you have right now, so you guys can think about what is happening here. So you can see that, right? This is a computer vision example. This is where see it in action coming into the picture, and you can see that, okay, there are rectangles, and how many rectangles have been created. So the image file format, what's the size of an image, black and white is none, adult content is saying like, is it an 18 plus content? No, yes, it's not an 18 plus content. And racy, gory or something, so there are no racy comments or anything, that is what they're saying. So it's all about that. And also, look at the magic here. So it's saying that it's in handwriting, yes, and it has a confidence of 98%, and that's the best score that it can do it. Post-it note, yes, it's a post-it note, yes, and it's also saying it has text, it has some design. Yep, it has some sort of a design, but it's not a kind of a design, but it's a letter, yes. It's a whiteboard, no, and see the confidence here. So it has less amount of confidence. And the purple is kind of an color here, I think it's magenta out there, but it has some sort of an confidence here, and it's saying that. And yes, let's see how much of optimization has been done right in front of you in here. Like, you as a developer who didn't know how to do machine learning and deep learning is now optimizing a lot of things. So let's say the future scenario, how it is. So meanwhile, let's say you have a number plate saying that K02 something, right? And you want to note that immediately, and you don't have time for it, you don't have sticky notes or something. So what you can do is you can just click a photo, and probably something like sending it to a police station or something, that might also not work because they are having hundreds of cases like this. So what you can do, you can automate all these kind of things. That's how it is. So I think let's just talk a little bit on neural network, because I wanted to give you this insight so that you understand why is a neural network architected today. So if you think of a neuron, I think how many of you are biology students before coming here? Like, were biology students before coming here? Like, I wanted to know how many of you did biology before coming here. Like PCMB guys. So you guys can talk about PCMB, PCMC or something. Like, I just wanted to know that, because a lot of times when you guys come up with neural network or something, PCMC guys won't understand it very well. So if the PCMB guy is there, he can help, or something as good as saying, okay, this is what we want to learn from, what do you want to do next, and things like that. So PCMB guys are here. If you guys are here, just say PCMB, or else just say BBB or something. It's enough. All right, you guys are too shy to say about it. That's not a problem. So let me just see you how a neural network works. In a human brain, that's the CPU of your entire body and things like that. That's what they say, right? So a lot of times it has a nucleus, it has an axon body, and it has myelin sheath and similar structures like this. Like, we are just talking about all these kind of fun thing, and there are some neuronal connectors, dendrites that are coming in, and this also has dendrites, and here we also call it as harbor. So just keep a note on all these things. I just wanted to say this because a lot of times when I explain about where is the requirement in learning this entire concepts and things like that, they like, okay, we didn't want that, but he explained it, but this is the requirement. When you come to the industry, this has a requirement here. So now neural network was already seen in the brain in a form of a neuron and the things like that. Now we wanted and something called as an system design approach, right? It's a system. At the end of the day, keep a note on this. Everything that you're architecting is a system. So your neural network is a system. So any ECE folks here, just say me ECE folks, ECE folks, electronics and communication engineering, electronics and communication engineering. You guys have a subject. Okay, so EC folks, you guys have a subject called as control system, and in that control system, you will be taught like design a system, input X, output F of X, and things like that. So we'll be talking in terms of that only. So keep a close eye on all these. So when I say something as a system, it is having a set of input. Okay, let me just change my pen here. All right. Okay, this is a blue one. Okay, now what's the thickness of that? Okay, I need to change to this, and that will be perfect. So it's all a system, right? At the end of the day, so you give an input X, you give an input X, and that goes through a system which has some black box. It's considered as a black box there, but we also know we are optimizing it for F only. And now Y will be the output, and the optimized output will be F of X. That's what we have right now, right? And now what we wanted was we wanted to simulate a neuron. So now it's all about getting that right functionalities, right? So this is a neuron to us right now, but this is still going to be TensorFlow or PyTorch at the end of the day. So this has f of x, and it has many inputs which are coming in. So let's say x1, x2, and xn. That's what we are talking here. And this has something called as a bias at the end of the day. And what happens is the function is set in such a way that it gives out f of x n plus b, which is equivalent to y right now. So keep this in mind. This is mx plus c, y is equal to mx plus c. This is what it's getting mapped towards, right? And neuron knows that it was used for passing in information, but here it's more towards processing that information. So let me just give you one thing. You draw a straight line, it's y2 minus y1, x2 minus x1, and things like that. That's your slope. And here you go. That's your slope at the end of the day. X will be the input, c will be some sort of a constant, and y will be the output. Clear? That's how it is. And they saw that okay, this is how the pattern are. But in industry, somebody saw that, you know what, it's not going to be just a straight line like this. It's also going to be magical. It's going to be something like this, like this, like this, like this, like this, like this, like this. It can be at any given point of time. Let's say the points come up here and come up here, and at this point it comes up here. Let's say this is the time and this is the speed of something. Let's say a man starts driving at this point of time, he reaches this speed and he now starts deaccelerating. He starts at this speed right now, and now he starts deaccelerating, he starts moving in here and things like that. So that's how it is. So somebody has to predict what would be the speed of that next move, and based on this experiences, saying that probably he was getting bored from here and here, he is now getting excited from here and here, he's getting more excited from here and here, and things like that. So that's how the pattern is getting learned here. So what you required was multiple amount of points, multiple amount of data, and things like that. But if you can see that to an extent, it has a relationship with lines, right? And this really gave us the motivation to put in much more amount of neural network. So what started as one neural network became one layer at the end of the day, which was extracting a lot of things. And the neural network was also used for processing. So every component that I'm talking here is a neuron at the end of the day. So keep a close eye on all these, because all these concepts talking in 1 hour is just going to be very hectic for me as well. So they started mapping in the resources. So now they got y1 and y2, and now they are saying Will E rise the speed? Will E fall in speed? And things like that. So that's a short amount of insights about it. So let's just go to some more demos in Azure itself so that we can start learning about it, and then we can go towards other solutions as well. So I want you to go click on this link, and this is the link that we can talk about. It's called as AI demos Microsoft.com. So this is how the solutions are being given out to you from Microsoft. So hands-on with AI, just go out there and learn it. So if you want machine learning, you can try out now. You can do a lot of machine learning. Okay, so you can do a back to AI demo. You can go here and check that out. So let's say I want to do something as custom vision is okay. Let's do analyze a video, right? So already there are some videos given from Microsoft. Select the person to see who has to appear in the video. Yes, I want this guy to appear in the video. And next is the key topic, virtual machines. Yes, sentiment positive. Yes, it was neutral and positive. So you guys can go and check out. Okay, this is how it is. And key annotations are abstract, screenshots, person, man, indoor, holding, sky, and everything. So you can see that there are a lot of laptops here, right? So you can see that there is a lot of laptops which are there here. Of course, there is sky. There is no sky, but because there was some shades here, I think probably they're talked about sky here, and also there are some movies here and things like that. So if you want, you can also get the transcript here. So this is how it is. So what is this service is called as? It's a video analyzer for media, and there is a service called as media service also. So you guys can check that out as well. So, and there are some more topics that we were supposed to discuss. It's also about responsible AI, Azure responsible AI challenges and risks. So let me just cover that. Azure responsible AI. Oh, sorry. So if you can think of what is this responsible AI principles is all about. So it's all about the fairness. We are talking about fairness here. Ka matlab, it should never give an biased result. Something as good as he's my friend, he's not my friend should never be there. It should be something like he's a friend, he's my classmate or something. So that's where fairness comes into the picture, and all these things are being talked here. So if you want to have transparency, so you can talk something as GitHub Onyx. Onyx is being done. So it's an open neural network exchange standard. You guys can go and contribute to this project as well. This project is doing phenomenal in the industry. Everybody in the industry wants this product, and it's an open source project. And you guys can go contribute here, and you can have your contribution status here as well. So that's how it is. And also, if you guys want to have some more demos on responsible AI, so what does an responsible AI means? So let's say something as good as I can do text analytics now. So I'm not a text guy or something, but I can do that. So let's say, hey, I want to know which college are you guys from? Like, which college are you guys from? Like, I wanted to know that. So any college people here? So I wanted to know which college are you guys from? I think there was yes comments coming up. So I wanted to know which college are you guys coming from. So okay, so you guys can type in your college name or things like that. So that will be fine. So okay, fine if you guys don't want it. So let's say let me just go for my demo so that I can show you. Hey, okay, BBC Vidyavadaka College of Engineering. Yeah, BBC. How are you folks? I am Vishwas from AZ Dev, India. I will be the speaker of the session. Now I click on it. It's saying that it's 91% positive, and I want to do entity extraction. So, hi, VVC is the entity, and how are your folks? It's not something that I wanted to write, but yeah, I just wrote it by mistake, but it's there. From AZ Dev India. So entities are nothing but the one which gives me a lot of information. So if I give entity search, so India is a country, you can see how the Bing session is. So you can go and search what are some of the places where you can really go and search this place. So something like India was there, and I can search about India here. So it's all automated, it's all given to you, and anything beyond it will obviously come. So how was the universe created, like you can do a lot of things like this. So Turing energy test, natural language, and things like that. So there are 17 billion parameters and things like that. So you guys can go check this article as well, so that you. Oh, you guys are from. Oh, okay. I guessed it right. Okay, sorry. This StreamYard gives me an error of lag of what you can say 30 seconds. So that's why it will be like that. So yeah, I think VBC was what was I guessed. Yeah, I think that's perfect. So you can see that there's a huge amount of market that can be created, right? Let's say something as good as somebody clicks on something that Nike can be created. So if I say Nike is a good brand, and of course Nike is a good brand, it's a positive thing, blah blah blah, and entities Nike is a good brand, and entity search comes with Nike, but it didn't give out Nike, but you can think about it. And if you think at AI at scale, why I'm talking about AI at scale, it's because a lot of times when you think of different amount of people coming in, different amount of people using your entire deployment, it's going to be a little chaotic. Something like somebody says, hey, I want a pizza. Somebody like, I want a margarita pizza. And something pizza has to be taken care, right? But margarita is the flavor of the pizza or the type of the pizza that we are talking. So when I'm talking about AI at scale, it's all about like different opportunities to learn from the given data in the real time. So this is where it is. So you guys can check that out. You guys can do a lot of demos. So I think probably doing a complete demo today would never be an satisfactory thing, because a lot of times you will also miss out on something. So I think the challenges and the risks that we talked about, machine learning, what is machine learning? All right. So if you guys want, there is one more slide of mine. I think crash course, Doppel crash course, deep learning crash course. Yes, I think NLP is not mine, but I did one session for them. But you guys can check that out as well. So I think let's talk about all these algorithms, and we'll just move on to architecting it as well. So this is the crash course wala thing. Okay, sorry, this is not the place for it, but happy birthday, folks. Yeah, perfect. It's on the stream, can't help it. All right, so that's it. This is a slide. This is a slide I've shared with you folks. So let me just come on the screen. So this is a slide where I do a lot of learning towards the crash courses and things like that. So you guys can start learning about all these things. So this is just a demo of it. If you go to the AI for radiology demo, there is huge amount of thing. And also a lot of things are being architected today. So don't worry about it. So just stay calm, I'll explain you everything. Okay, so we talked about AI challenges, yes, as well. So common artificial intelligence workload also we talked, and a lot of things. So let's go. to some algorithms. We'll go to some algorithms so that you guys can start learning about it. Okay. So now we have talked about something called as where does the neural network come and fit in, and where can we architect it. Now let's take to some regression. So what's a regression? So it's a statistical method used in finance or investing discipline that attempts to determine the strength and the characteristic of the relationship between one dependent variable using denoted by y and a series of other variables which are independent variables. So in a same old architecture, if I can say you, uh, oh right, let me just go down. Yes, if I say you, x was an independent one, p and d, p and d, and D, independent variable, and ma'am, I'm in a session. I'll call you later. Okay, I'm in a session. Okay, I'll call you later. So, yeah, it comes up. So can't help it. So okay, let me just go to that. All right, let me just get it. Why is this? All right, so x is an independent variable. Let me just write it a little bigger. So x gets in. So x1 and x2 independent. So it's not dependent on any factor. Something as time is something which is moving, right? Time 1 second, 2 seconds. It's just going on. It's something which is there. But on a 1 second, what will be the value of x on transform to y? One. Let's say it's y1. So what's the value of x2 at the value of y2? It's independent, right? What will be the transformation on that input data, and what will be the learning that I'll be getting from that? It's independent. So this is where what you do is in regression. So if anybody asks you in interview or something saying that, what, this is how the technologies and nonsense and things like that, let's say them regression problem is more towards the line fitting, something like you have a data point here. So let me just take red pen here. Red, it's this point here. Oh sorry, I can't do a point here. So this point here, this point here, and there's a point here, there's a point here. So now let's say there are one more classes which are coming up, right? So I'll use a blue pen for that. So I'll use a blue pen for that so you guys can understand. So it's here, 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 here. And one might go here, one might come up here, one might come up here. So now you want to make sure that a relationship comes into the picture. Something as good as, let's just draw a line between the relationship that we are supposed to get. Something as good as this. So I am leaving out these four features from class 1, the red class or something. And most of the red ones are here. Of course, there are blue ones which are missing. That's okay for the second class. But I've made sure that I've drawn a proper line here which separates the distance between merging of these points, the blue classes and the red classes out here. So this is what I'm doing here. So at the end of the day, what you're doing is you're making sure that you build a relationship through a line or something. So it can be as good as this also. It can be as good as this also. But which is the better fit? This. So this is where you come into the picture. So this is where regression is being used. So let me just give you a quick example. Okay. So let me just give you a resource for how you can find research papers here. So there is something called as Azure, and this is a platform where you researchers from MIT, research from IIT, researchers from top-notch institution and top-notch conferences open source their papers out there. So science is more accessible. So we are talking about AI for accessibility, right? So I'll explain you who don't do those who do not understand what is accessibility is all about. So let's say 3 foot. I'm 5'9". Yeah, I'm 5'9". So a decent height. I can lift myself out there. I can push myself out there and get an something which is as good as something like 5'11" or something. The same thing can't be done by a 3 foot guy or a 4 foot guy, right? 5'11" I can reach and I can get it. Like I can raise my toes and I can start working towards it. But something as good as 4 foot guy can't do it. So they're also good. They're also a human being, and time, a lot of times when we are architecting a solution on kind of a platform like this, there has to be something called as accessibility in our mind. Something like, can a person who is a farmer use my application? So today, when I speak of accessibility, something like voice assistant is coming up, right? So when a voice assistant comes into the picture, a lot of times a solution is being architected. Something as good as, I'm writing on a graphic tablet, right? I think probably some of your teachers might use the graphic tablet. To me, when I started it, it was very tough. I had to learn over and over again. But now I'm accustomed to it. So if you ask me to do a slide, probably I will get irritated about doing a slide on deep learning. But today, if you ask me something like, can you come and do a session on your graphic tablet? Yes, I can do that. That's how accessibility is getting defined. So it's not complete comfort zone, but it's something like, we are not creating one, but we are giving them one, which can be created. So something as good as that. So keep a close eye on all these kind of words that we are coming up. It's not jargonish. It's not jargonish. At the end of the day, I'm not going to half of what we are supposed to talk in deep learning or anything. All right, he has to go for the next session. So this is how regression works. So if you want to learn a lot about all these kind of research papers, this is the best source that you can reach out to. And if you want something as good as cloud computing, just go type in this. And if you want a very recent paper, you can go to that. How many of you are in final years? You guys have to do one, this one, right? You guys have to do one, what do you call, a paper presentation or something. And your teachers will ask you, get me an IEEE paper. Guess what? Here is the one. Here, when you see what is happening here, is all best papers which are given in best conferences have been given out here, and all these are international authors and they come up with great amount of research papers. So, and one more thing, Uber, open source, GitHub, you guys can go and contribute to any amount of projects which are there here. Please go see all these kind of contributions that are happening. uh, and you guys can learn a lot. You guys can learn a lot. And also there is one more thing. There is Netflix open source GitHub. So you guys can see amazing projects have been given out from Netflix. So do reach out to them in giving out your contributions. They will obviously help you, because a lot of these research is happening in companies like this. And if you want, Uber has research papers as well. So I think Uber research paper, research, if you can go Uber publications, yes. So a lot of research papers have been given here, so you need not have to worry about it. So here's the link. I think this is the link that I'm just sharing right now. And also, let me just say one more thing. If you want to learn something in terms of all the things, just reach out to me on LinkedIn. It's not the end of the session, but I'm giving you the resources where you can go and check out some amazing resources which are there. So if you are on LinkedIn, so yes, I'm a YouTuber. So there is a section called as feature, and there are n number of notebooks that I've already written. So click on show all featured items in my featured section in LinkedIn. So you guys can go check out all the things. And of course, I do have a YouTube channel. So do subscribe to that. So its name is Vishwas Narayan. So amazing researchers, amazing people from the world of deep learning. And let me say you one thing. This guy is my brother, and he was from your college, VVC itself. So his name is Chetan Nagesh Pal, and he was your alumni. And yeah, I think if any of your teachers recognize him, he's from your college. So in fact, do subscribe to my channel. It will increase a lot of digital presence in my space as well. So moving on to all these things, I just wanted to give you some resources out there. So this is my channel and this is my podcast, by the way. You guys can go check this out. I think I can write this. I can write this. So click on this link, go to the YouTube channel, just see all the podcasts that I've done. I think this is the YouTube channel that we have right now. So yeah, that's how it is. So this is the podcast playlist. Yeah. So do reach out to me on LinkedIn, Twitter, whatever it is, and let's just get learning. A last algorithm that I want to show is about classification and clustering. All right, clustering is also one of my favorites. So let's do it. So let's say tomorrow I say x1. So let me just do that. Yes, it's here. So the problem with OneNote is you have to change the thickness of the content. So x1 is something that I wanted to learn, and x2 is also something that I wanted to learn. And let's say I do some market research. So x1 is greater, x2 is lesser, and I say salary. X1 gives me greater salary, x2 also gives me greater salary, right? That's how it is. And also people. So x1 has less amount of people, x2 has more amount of people. So now I want to classify in such a way that should I go to x1 job or should I go to x2 job? In such a way that I want to understand what is it all about when we are architecting a solution on all these kind of things. So once you think of all these kind of parameters that you want to research upon and the things like that, it goes a little bit impossible, right? Impossible in terms of getting where should I get in. Salary is good, people is good here, but people is very less here. Salary is good, market research is also doing amazing in terms of my research. What should I do now? So should I choose x1 or x2? In such a way, there are something called as an cancer problem statements. Let's say this is the brain. I'm just hypothetically drawing a brain. This is cerebellum, cerebella, and this will be medulla. Just a simple annotation. So this is frontal lobe, occipital lobe, parietal lobe, and things like that. So different ways in which they are working. So let's say I have a tumor here. And I want to remove this and this also. But to me, if I remove it, it's going to affect my vision. To me, if I remove it, it's not going to affect. And that's how the classification is. And also based on the regions, you can start classifying. So I just give you an advanced example of how can this research work here. This is what I talked about, but this is where you can also reach out to. And a lot of time all these kind of research starts working, like where can I reach out to the best. So a classification problem statement is something like you have x1, x2, x3, some points here, and you have another class here saying that this is the blue class and things like that. So learning the pattern starting from zero, this is what the fate of this entire data point is. Starting from zero, this is what the fate of an entire data point is all about, right? So this is where we are coming into the picture. This is where we are talking about I'm learning some equations here, right? This is x, this is y. Oh, sorry for that, x, it's very bad. So this is y, and I'm learning a pattern out here. So let's say tomorrow I get a data point black here, and also let's say I get a data point blue here and blue here. So it should never be something like I've been seeing an rising curve for a long term. Should I go here or should I go here? Something like it should always try to go here or here at least, right? And that is where classification comes into the picture, saying that based on the learning, classify me X1 or X2. That is class 1 or class 2. So if you are getting confused, I'll write it as C1 and C2. And this is what you have to do. All right, C2. So C2 is supposed to be done. How? Based on the learning that is happening. So in regression, it's all about the real-time fitting of the line. That's what we showed about, going to a line, fitting out, and saying which is the best point to separate out maximum amount of the data in the real time. But in classification, it's all about learning from the data already, and then in the future data points, classifying it as C1 or C2. That's how it is. And if you want some more definition about clustering, oh sorry, Gauri, okay, software artist. Okay, so okay, this is my sister's laptop, not mine. So his that's a college sir who is just giving that. I think what we can do is clustering in machine learning. So what is clustering in machine learning? Machine learning, we often have a lot of examples where first step to understand all of them. So grouping of unlabeled data. So in your entire machine learning research, there is something called as supervised, semi-supervised, and unsupervised, right? So what I just taught you about supervised was your regression, because there was already data points and now it's all about getting it. Even your classification to some extent is an supervised problem statement. So it can also be semi-supervised in such a way that I'm just getting the data right now and I'm classifying C1 and C2 later, and that also becomes a semi-supervised learning. So let me say you the quick examples here. So don't worry about it. We all have been through that phase. Okay, so don't worry about that. So let me just remove my share screen for a while. So let me just explain you how this is. Okay, so a supervised learning, something as good as a baby going out here and falling down and saying that "Mummy, atta" or something. You know, Kannada barata yargaru. Kannada barangidre Kannada anta bariri. So I'll say you one thing. I'll talk in English because this recording will be seen by all the people, and Microsoft sees this. So I have to speak in English. So profession can't help it. So let me just give you an example. The baby goes and falls down and says that, what, this is what happened to me. This is what I learned from me. Mummy, I just fell down. Things like that. And next time, before it falls down, it calls mummy at the end of the day. And now, let's say it sees something shiny and it goes to the diya or something called as deepa, the diya, deepa, or something called as a lamp. And now, the problem with that is it just goes there, sees the shiny thing, and now says that, what, this is worse. Let me just touch it and things like that. This is making me so frustrated. I just want to touch it. And once it touches it, it gets hurt and it starts learning. So now it's an unsupervised learning in such a way that baby started learning on its own. But now something like as good as mother saying to the baby that, what, don't go there, you'll fall. Based on the previous experience of it falling, it starts learning about, hey, what, this is what happened to me and I should never fall. My mom is saying me, I will fall there. That's called a supervised learning. So it's all about that kind of a learning that is coming in. So unsupervised is that example, baby learning on its own. Supervised is mother teaching the baby. Semi-supervised is something like as good as baby goes and lifts the bottle or something. Like let's say it lifts something sharp and now it has no point in it and it now gets hurt, and something like mother saying, okay, you got hurt, Abbu Agudu, and things like that. So this is how it is. All these kind of learning happens on the go, and that is how the classification, the clustering is all about. So let me just give you a simple example. Okay. All right. So all right. Then let's just go to what is a clustering all about. So let me just explain you based on the data examples. Okay. So how many of you are final years here? Like, of course, there is a lag in the stream, but I want to know how many of you are in final years right now. So how many of you are in final years right now? I think I'm going to block you. Sorry for that. So how many of you are in final years right now? Final years, final years. Okay, I asked you how many of you are in final years right now. So this algorithm, if you guys get to know it, probably this is going to help you guys in solving much more bigger problems tomorrow. Something like, okay, some of your teachers might be researching on EEG, electroencephalography, or EMG, like these are used in matrices and different sensors, right? So let me just give you that quick insights as soon as possible. So now, okay, my OneNotes is here. So let me just go to that. So as good as somebody will have a cardiac arrest. Okay, let's do a cardiac arrest. So your electro ECG data comes into the picture, and that will be having a lot of pico and things like that. So it's a hypothetical curve that I just draw. But if you want to really go and see what an ECG curve is all about, you can see that. This is how it is. Pico, Q curve, and things like that. PR T, Q, S, and things like that. So this is how your ECG data comes out into the picture based on the patterns that are coming in. That comes in. So let me just copy this and paste it over there so that you guys can understand. So this is a very bad thing, right? So let's put this in x-axis and y-axis. Okay, is my my screen is shared. I just want to know that. Oh yeah, it's shared. Perfect. Because I touched on it, I didn't know how it went. So this is y-axis. So this is 0, and this is some point, which is here. Point is here. Point is here. Point is here. But let me see you how the data will be. It's not this point, this point, this point here. It will be continuous here, and cardiac arrhythmia and things like that. There is different amount of research that comes in. Okay, so if you are not a medical, also I'm giving you very short insights. Okay, I'll show you one book. Be in touch here. All right. So okay, so now let me just share you the ultimate truth of my life. So I've read these books. Okay, so let me just keep it properly. So these books, I had to read this big book in order to solve that problem statement. It doesn't get solved like that. So I've read all these books, and I've learned how to read all these kind of and readings. So if I will never allow anybody to have a cardiac arrest in my home for sure. So that's how it is. So let's just talk about it in a future while, and let's just talk about it. So it's all a continuous data, and that will be in a form of 0.7671, 0.7602, or something like that. And now, based on the points that are being told as healthy or unhealthy, this is where you're architecting a solution, right? So where does the cluster fit in? So these are some set of data which comes in like this. So I'm just drawing an hypothetical one. So it will be kind of a thing like that. So based on the shift that is being seen here, based on the length that has been seen here. It has to architect a solution for it. And now, where does the clustering fit in? Something like it sees that until this point he's healthy, until this point he is unhealthy. This is where clustering comes into the role. What does clustering do? So it collects all the data points. Let's say, let me just clear off all these things. So just clear off all the things here. So let's say in an x-axis and an y-axis, there are some set of data which is already created. And let's me draw one more thing. There are some more sets of data which is already being created. 1, 2, 3, 4, 5, 6. What is 3, 4, 5, 6? And there is one more set of data which is already being collected. 2, 3, 4, 5, 6. Right? So now what does your clustering algorithm does is it now categorizes based on the data points which are coming in, and now it basically draws that relationship. That's how clustering is all about. So even if you see that clustering graph, so if you see that it's all about learning, correlating the relationship on the real time. So I think there was one more notebook from my side. It was called as Gates. Yep, I have it. Yep, I have it. Yep, I have it. I have not lost it. So I can give you that quick insights right now and here. Right now and here, I can give you that quick insights. So this is an alpha curve which is now generated based on the. Okay, I can just boost up the little bit space. So these are some gates that we just wanted to draw, and we are now drawing an alpha function and things like that. And guess what? This is the input spike in the brain EEG that I just simulated using this kind of a relationship, right? And now I'm just classifying it with an accuracy of 99%. That's good. And also I'm just doing this. This is also telling me the loss function and things like that. And guess what? This is where I just did a little bit of sigmoid optimization and the things like that. And all the learning that happened here is all coming here. So all these was kind of a regression kind of a problem statement, but it's now also trying to learn on its own. And also just look at this scenario. This is the worst thing that can happen to you when you're researching on something, and a lot of times this changes. So what I'll do is I'll list out all these articles in the Google Docs here. So let me just go to the Google Docs. Let me just come to you folks so that you guys can understand a lot of things. I think you guys are very shy to talk, man. Some guys start talking. Like, that's the worst part about it. So start learning how to speak. I think you guys will learn a lot. I think all these resources will be there in the resources here. So this will be the notebook. So I'll be listing out all these notebooks in the Google Docs. So don't worry about that. So all these are just the learning that happened. So as soon as we progress every single day, we'll talk about epochs and the things like that. So don't worry about that. So this is just a simple example of low code solution that is coming up here. So of course there is ruffle Nadal, and we just do the racket and the things like that, and see the magic of all these things. We all started learning here. Like this was just a simple bit of code that I just wrote in order to extract the information, right? Everything has been given out to me. So if somebody can annotate, I can give you an edit access, so you guys can come and annotate here, so I can give you the edit access here. So these are the low code solutions that I'm talking here in the world today, which are already available. And this is an advanced notebook, like literally it's a very advanced notebook. Took me a month to write it. Might look very simple, but amount of insights that are given here, it's way beyond what I could have ever done. So yeah, I think you guys can start learning from here as well. Please learn, because a lot of times learning requires, like, it should also be an humble attempt from your side to learn something. So yeah, I think that's what it is all about. But let me just give you other notebooks. Yeah, this is also advanced one. But start learning. Never underestimate your own potentials. You can be something good tomorrow. You can be doing a lot tomorrow. So never underestimate yourself. So okay, so all right, lot of visualization notebooks that I wrote on my LinkedIn also is there, but I'll be sharing it here so that you guys can see it. So better don't worry, all the notebooks, all of these things are being given to you folks. So if you want an advanced introduction to deep learning, so if you guys are not bored, stay with me, please, because a lot of these learning can't be happening in one day only. So a lot of times it's all about we learning together and we growing together. So I'm ready to teach you folks. So just be here. Okay. So I'm using a Python 3.7.12 version that was when available January 30th. Yes, this year. And now I'm using no CPU, no GPUs at all. So yeah, that's what I'm using. So what I was talking about, all these things, I said data points can't just be operated as x1 and x2. It should be going to a neural network in a form of a tensor, and that's a whole new complexity, right? We can't optimize that for every little thing. So what we do, we use packages like TensorFlow or PyTorch, and we start architecting our solutions with it. So torch.ones are here. So this is just like writing a metric. And if you guys want to learn something new, don't worry. We'll be sharing you some cheat sheets for NumPy as well. So keep a note on that. So x plus one, yes, x plus y is what we had, and we just started working towards it. You can also do x plus one here as well, but you should also give it in a form of ones matrices only. So that's how it comes up. So it's all there, and see the magic of this, man. The I didn't do much of a work, and lot of linear leaky relu optimization, lazy linear, and all these kind of optimization functions are already there for me, and I just need to use them, and I need to architect my solution. That's it. And that's how all these things are. So I think last bit is what I really wanted to explain. So yeah, I think I'll explain you that last bit, and you guys can start moving towards your this one. So okay, let me just draw an neural network. So I'm categorizing it as TA and TB, and I'm putting in different data points. This is what your line fitting regression problem was all about, and I've done it in bare minimum NumPy and also PyTorch. So keep a close eye on all these things. So now what I'm doing is I'm now plotting all these things. Now your data can't be put in just like that, right? So I'm putting in the TU range, and I'm putting all these different plots that are coming in. So whatever I did as a plot here, as a relationship learned versus the actual data, is not now getting fitted. So what I'm now doing is I'm just putting all these data inside and neural network, saying it's in a form of a tensor. So this is what I'm saying, putting it in a form of tensor. So what is this? It's nothing but data at the end of the day. So yeah, and then we started working on it, and n number of samples were already being created, n number of samples were already getting trained. Different values came in a form of tensors only, and guess what? I'm now collecting all these kind of data sets. That's what that code was, and I'm now thinking about different biases that might come in, and now I'm training different training loops and the things like that. And now the learning has already been created, and see the magic. The data which I just gave in was the relationship, the known truth, the predicted data from the neural network. Yes, of course, it was very close in predicting all these things, and also the collected data. So this is what your neural network was all about. So all your regression and everything done in simple set of lines of code. So that was it all about. So I think the other things, it's very easy to learn, because it took me a time. Of course it took me time. I'm not saying that I knew it from the day one. No, it took me time, but I started learning about it. So it's all about that. So I'm also giving you some notebooks which does give you a lot of TensorFlow and all these kind of things. So keep an eye on all these kind of notebooks, because a lot of times it's all about reaching out to the best resources as well. Why do you require a TensorFlow Lite? It's because all these tasks that I'm doing is compute intensive. It's compute intensive. And this can be running on an edge computer. What's an edge computer? It's just like your mobile. It has very tight amount of battery. It has very tight amount of processing power. That is, your CPU is not up to like 5 gigahertz or 10 gigahertz. Like 5 gigahertz is max we can go, but like I'm just making an cloud based approach. 10 gigahertz is what you can go as a max, right? So that's what we are talking about. So when you talk about edge computing, it's very complex, right? So this is where you are supposed to go on and get in with all these kind of things. And this is where edge deployments comes into the picture, because your phone is an edge, though it's trained on a multi-cloud approach, but it should be an edge. So this is where TF Lite comes into the picture and you can start using it. I think I'll put in the TF Lite. Yes, I think so. And this is just an conversion framework. We'll be going about it day after tomorrow, not today or tomorrow. Sorry for that. It takes a lot of understanding that is required. So this is what we wanted to give for you folks. And a lot of learning has to happen from your side. So don't be lazy. Don't be lazy. I'm making that statement. Don't be lazy, because a lot of things can change in the market right now. So keep a close eye on all these things. So I think a lot of resources shared from me. So don't worry. Just take a day or a two to learn each and every notebook, or else a week to learn each and every notebook. Probably within 3 months or 4 months, you'll be good enough to go on. So I think this is a module from Facebook. This is called as Detectron, and this is used in a production system, and lot of, what you can say, a lot of companies use them today. So you guys can do that. And of course, sometimes I don't love doing slides. I do notebooks like this. So I love doing notebooks like this. So you guys can go check this out as well. So okay, so you can start learning. So, and also, of course, I used to do a lot of paid sessions out there for different folks. We used to just go out there and we used to start learning a lot about neural network. We used to do 14-day demos for code my paper and the things like that. So if you want to code a paper and the things like that on a real time, you can just do that as well. So a lot of things, lot of notebooks. I'll just keep explaining about them. Like if you just go back to all these notebooks, it'll be helpful for you folks. So that's why I'm helping you folks right now. I think this is not going to work for you folks. Pandas cheat sheet. I think there's a lot of updation that has to be done, and I'll be updating that soon in that place. And of course, YOLO is from one of the amazing computer scientists, and he has a TED talk. I'll share you that TED talk. Don't worry about that. All right, so let me just go here and clear all the tabs on the right. So Joseph Redman is one of those guys, and YOLO creator Joseph Redman. He has an amazing blog. Redman. Okay, let me just give you that quick insight. So here's the Joseph Redman. He has an amazing TED talk. Do watch it. It's called as Computers Can See. Yes, it's a TED talk. Just go see this kind of a talk, and you will learn a lot from all these kind of resources and things like that. So yes, I think Sanjana Shetty, yeah, BBC. Thank you so much, folks. This is the list of resources that I've shared. The last comment that has been given by me is something that I've shared here. So do check this out. This is going to be your humble attempt in order to understand what is this deep learning market all about. So when you enter a marketplace, how you have to enter, probably by all these knowledge that are embedded in this entire docs. Let's go see all these docs. All these docs are so important tomorrow, because when you go for the interview, it's all still the same old basic questions that are being asked, basic formulas that are being asked. Like, I can't explain you that in 1.5 hour or 1 day. It's very complex. Like, how to show you how the neural network is and the things like that. So tomorrow, what I'll be planning is I'll be showing you a walkthrough of one notebook that is there here. Yeah, probably it can be something as learning PyTorch or something, learn basics PyTorch or something. Just go reach out to that. And what I'll be doing is I'll be showing you some demos on machine learning, cognitive services from the Azure. And also, I would love for you guys to join this WhatsApp group that I'll be creating right now. So I want somebody to ping me on LinkedIn so that I can share you that WhatsApp group link, so that you guys can start reaching out to me right now. So I think Avinash has commented. So yeah, I think Avinash, I can share you the link for the WhatsApp, so you guys can go and check out all the link. I just want you guys to be in the group so that we all can start learning there. So, and also make sure that you join our Azure Developer Community channel, Mysore Community, Mysore. Or else you can also contribute to us through easydev.reskill, SKILLL, 3 L, so we can start learning. And thank you so much, folks. If you guys have any queries, reach out to me on LinkedIn. So this is my LinkedIn here. This is the LinkedIn. And also do subscribe to my channel, because a lot of great resources are coming up on my channel, so you guys can communicate a lot of things over my channel as well. So if you guys want to learn something about, you guys can go reach out to me at any given platforms. So thank you so much, folks. Make sure that you all learn. Make sure that you connect with me on LinkedIn, so we can keep that relationship going on and on. So thank you so much, folks. See you tomorrow. Bye. Have anything